For today's lesson, our focus standard comes from grade 7, Statistics and Probability, Standard 7. Compare probabilities in uniform and non-uniform models. For today's lesson, our unit continues to be on probability, and today's is called Completing Probability Models. Our essential question is, how do we complete probability models to make predictions? Please take a moment pausing the video as always to copy down the topic and essential question along with today's date, set up your question column in your note column, and resume the video when you're ready to begin. So in today's lesson, we have to start out with a fact that all mathematicians have to agree to in order to use probability models to make predictions. And that fact is that a valid probability model must have a total of 1, meaning in a percentage form that it takes into account 100% of the data. So for our first example, we're going to take a look at an ice cream truck, Casey Scoops, that is using their data to make some predictions. So they brought their truck to the Selwood Student Showcase, and here's the data that they recorded. 47 customers chose chocolate, 33 chose vanilla, and 64 chose strawberry. They want to use that data to determine what is the probability that vanilla will be the next flavor served. Okay. So we want to complete this model. Model in this case is a table showing all of our data. And if we're talking about probabilities, we want to think about what are the different forms we can write probabilities. So thinking back to our very first video lesson of this unit, that would be fractions, decimals, or percents. Well, if we want to do that, what else do we need to know? We need to know the total number of customers. So we need to take their data of 47 who chose chocolate, 33 who chose vanilla, and 64 who chose strawberry, and turn those into a fraction, decimal, or percent of their total customers. So we need to add these numbers up. It's okay to use a calculator for this. So let's see, go ahead and grab one or do it on the side of your paper, scratch paper, add that up. So when we add that all up, we get 144. Well, now we can write these as fractions. Right? It would be 47 over 144. Alright. These definitely have fractions that could be reduced. If we reduce this one, I know 3 is a factor of 33. It's also a factor of 144. So if we bring that calculator back up, reduce that fraction, 11 and 48. And I know that 64 and 144 can be reduced also. We can see that 4 is a factor, 16 is also a factor. So if we reduce both of those by the greatest common factor of 16, let's do that, pause the video, and come back and compare. So here are those fractions in simplest form. So we know the probability as a fraction of what we would expect for each of the flavors. They're asking specifically for vanilla, and so it looks like 11 out of 48 is what we would expect for people to want vanilla, but sometimes that fraction isn't as helpful. So we're going to turn that fraction into a decimal. Let's clear our work from before and take 11 divided by 48. And we get this decimal. So percents are out of 100, so it's 0 and 22 hundredths, but we want to use this 9 to round that up. So we would say that would be equal to 0 and 23 hundredths, or 23%. So 23% would be the probability that we would expect vanilla to be the next flavor served. So let's go ahead and take a look at our next question. For this question, we're being asked to examine the probability model for the Portland Trail Blazers' top 4 scores based on 2017-18 shooting percentages. I got some of these numbers from ESPN. And we want to know, is this a valid probability model? So going back to that fact that we talked about at the start of this lesson. So here are their top 4 shooters of last season. So CJ McCollum, looking at 24%, Damian Lillard, 17%, Al-Farouq Aminu, 16%, and Jusuf Nurkic for 10%. And that's, we want to know, is this valid? Well, you refer back up to your notes. Valid probability means that we're taking in 100% of their data on points scored and shooting percentages. Well, just from looking at this, one thing about basketball is I know that there's more than 4 players on the team. So one of my questions is, am I taking into all of the players or just some of the players? I can confirm that by adding these decimals up and seeing, does it equal 1 whole? Well, just looking at doing some estimation, I'm going to guess not. But let's actually add that up. So I've done that here, and you can check my work, but if we add this all up, we should get 0 and 67/100ths. That's not equal to 1. So that means we definitely have left some players out. So while these numbers might be true for these players, I don't see data that adds up to 1 whole. So it would not be useful or accurate. It's not going to be valid for me to use this probability model to make any predictions. So we would say that no, this does not equal 1. It's not a valid probability model. Let's take a look at one last question. I'm going to take a look at some data that I could have been collecting on my class periods and seeing which class is getting the ready position score to beat, and I want to make some predictions. So in the next 20 school days, how many times would I expect period 3 to be the class with the ready position to beat? Well, period 3 is missing. So what am I going to need to do? Well, for this to be valid, I need to look at the data I have and make sure it adds up to 1 whole, or use that to figure out period 3. So period 1, and I'm just going to display this here, was at 2/10. Period 2 is at 3/10. Missing the data for period 3. Period 5 has 15/100ths, or 15%, and period 7 has 10%. And I should tell you that these are probabilities based as decimals. So if I add that all up, and here are those numbers again, I get 0 and 75/100ths, and that's with adding these 4 classes. So I need to make sure that I also, I can use that to figure out what period 3 is, right? Because if I take 100% of the data, 1 whole, I can subtract what I have, and what's left should be period 3. And sure enough, if I do that, you may have figured this out already, 1 subtracting 75/100ths is 25%, or 25/100ths. So period 3, we could draw that in. Now I can use this to decide how many days out of the next 20 would period 3 be the class to beat. So we can think back to our last video and use that same formula. Do you remember what it was? We took the probability, well, in this case 25% for period 3, and we multiply it by the number of trials. 20 would be our number of trials, and that will lead us to our prediction. So what do you think it's going to be? Take a minute to figure that out. Well, let's see if we agree. I took 0 and 25/100ths times 20, and I got 5. So that means I would expect that period 3 would be the class with the ready position score to beat 5 times out of the next 20 school days. That's going to conclude our video, so make sure to leave room for the summary, make sure your notes are complete, and come ready to look at more problems like this in class.